Hey everyone, ever tried explaining a TikTok to your AI? You know, those fast-paced, info-packed videos that blend visuals, sound, and storytelling. While today's AI is pretty good at recognizing a cat in a photo or describing a static image, it's way less confident when it comes to videos, especially short ones. Why? Because videos aren't just a bunch of stills. They're dynamic, layered, and full of context that changes every second. That's where Kwai Keye-VL comes in. This new AI model from Kuaishou isn't just another language or vision tool. It's a multimodal giant designed to understand short videos like humans do. And it's blowing the competition out of the water. So how does it work? Let's break it down. First, the problem. Most AI models struggle with videos because they're too busy processing individual frames to catch the big picture. Kwai Keye-VL solves this by training on over 600 billion tokens of data. That's like a library of textbooks, but focused on videos. Think of it as teaching the AI to watch hours of TikToks, YouTube clips, and social media content, not just static images. But data alone isn't enough. The team engineered a 4-stage training process to align vision and language. Imagine teaching a kid to read by first showing them pictures, then words, then sentences, and finally full stories. Kwai Keye-VL does something similar. It starts by learning basic visual patterns, then builds up to understanding how words and images connect, and finally tackles complex reasoning, like figuring out why a video's funny or what's happening in a fast-cut scene. Here's the real kicker, a 2-phase post-training boost. The first phase teaches the model to follow instructions, like describe this video or summarize the action. The second phase. It's all about reasoning. The model learns when to think deeply and when to skip the extra steps. How? By mixing 5 types of data. Thinking, where the AI explains its process. Non-thinking, quick answers. Auto-think, self-guided reasoning. Think with image, combining visuals and text and high-quality videos. It's like giving the AI a toolbox of strategies to tackle any video scenario. And then there's the reinforcement learning part. Think of it as a teacher correcting the AI's mistakes, like stopping it from repeating the same answer or getting stuck on irrelevant details. The result? A model that's not just smart, but wise about when and how to use its smarts. The proof? Kwai Keye-VL outperforms other models on both video-specific tasks and general image challenges. The team even created a new benchmark, KC-MMBench, to test real-world short video scenarios, and Keye-VL dominated. Human evaluators also said it feels more natural and intuitive than other models. So what's next? This isn't just a tech upgrade. It's a shift in how AI interacts with our digital world. From social media to education, Kwai Keye-VL is paving the way for smarter, more intuitive AI. Let's dive deeper into the technical innovations that make this possible. One key challenge in video processing is variable input sizes. Think of it like a party where some guests bring a single snack and others show up with a whole buffet. A 10-second video needs way more processing power than a single photo. To keep things fair, researchers use a global greedy balancing strategy. Imagine a traffic cop sorting cars into lanes based on how much fuel, computational power, each vehicle needs. At every step, the system checks how much work each task requires and sends it to the lane with the lightest load. This keeps everything running smoothly, like making sure no one's stuck waiting at a buffet while others overfill their plates. But what if the power goes out during training? That's where sample-level auto-resume saves the day. It's like having a backup generator that kicks in mid-sentence during a blackout. This system saves both the model's progress and the exact data it was processing. So when the lights come back, it picks up where it left off. No manual restarts needed. It's a game changer for reliability, especially when training models on massive datasets. Now let's talk about post-training improvements. Researchers updated Keye-VL to handle complex architectures and video inputs, making responses faster. They also used multiple reward models during reinforcement learning. Think of it as having a team of judges instead of one, which speeds up decision-making. These tweaks aren't just about speed, they're about making AI more adaptable and efficient. So how did these upgrades stack up? On ImageNet benchmarks, Keye-VL's variants showed impressive stability. With 1D interpolation, there was a slight drop in performance, like a dancer missing a step. But with 2D row P modifications, it nailed the routine, matching the base model's accuracy. And the numbers? Keye-VL crushed competitors on, proving its superiority in real-world scenarios. Ever wonder how AI learns to solve problems without just cheating? Imagine training a robot to solve math puzzles. If the same puzzle shows up in both practice and the final test, the robot might just remember the answer, kind of like cheating on a test by studying the exact questions. That's called data leakage, and it's a big no-no for AI. So how do scientists stop this? They use clever tools like pHash and minHash. Think of pHash as a fingerprint for images. It turns a picture into a 64-bit code, like a unique ID. Then minHash groups similar images together. If a photo has been seen before in training, it gets filtered out. It's like making sure the AI studies new problems, not just memorizing old ones. But it's not just about images. For text, researchers use a model called CLIP, which understands both words and pictures. They check if a question-image pair is too similar, like over 98% for images or 50% for text. If it is, they toss it out. This keeps the AI from taking shortcuts and forces it to actually learn the math or science behind the answers. Why does this matter? These methods were tested across 29 different challenges, from math problems to analyzing charts. By cleaning data thoroughly, scientists ensure AI models are evaluated fairly, no cramming allowed. It's like giving a student a real exam, instead of letting them study the exact questions. The bottom line: as AI tackles real-world tasks, like diagnosing diseases or solving complex equations, keeping training data clean is key. It's not just about making AI smarter, it's about making it reliable. After all, we want AI to earn its skills, not just luck into the right answers. Next time you see AI doing something impressive, remember, behind the scenes, scientists are working hard to make sure it's learning, not cheating. Thanks for watching, stay curious, and let's keep exploring the future of AI together.